leading telecom service provider in the US with 154 million subscribers as of 2019. So oftentimes I get this request. Uh, am I audible? Ca- Can somebody use the chat window? Yeah, all right. Thank you. Yeah, so oftentimes I get questions from all of my friends, my ex-employees, my family asking me, what exactly is a data scientist? What do you do at work? How is it different from a research scientist who is working at NASA, or a bioscientist who is working in a laboratory inventing some medicine, or a quantum scientist? So I wanted to address that gap today, the general perception about data scientist, and talk you through some of my work, what I do in my office. I also wanted to show how anyone can become a data scientist, how to do that smartly, regardless of their educational qualifications, regardless of their previous experience or any other qualifications. So here's my agenda for today. I'll be splitting the whole session into four different sessions. I would be talking about what exactly is data science, uh, what does data scientists do, and then if you are interested in the first two, I'll uh, cover the third topic on how to shift your focus to a data science career. I see there are a lot of students in today's session, so I hope this third section would be of use to you. And in the final part, we can make it more interactive. You can ask any questions that you have about data science in general, or any career related questions related to data science. Do you know that IBM has predicted that there is going to be 28% increase in data scientist jobs in the US for the year 2020? Including that, there are going to be 2.7 million job postings with respect to data analytics, data analysis, data science, and analytics manager in the year 2020. Hi all, welcome to the session, A Data Scientist Journey. So here's my profile. I graduated in electronics and communication. I did my BTech, graduated in the year 2008. Since then, I worked with few organizations like Wipro, Samba, which is a bank in Saudi Arabia. I worked as a software developer with both these organizations. And it was in year 2013, I started thinking about a career switch. So I wanted to move to a more business oriented role, but at the same time, not leave my technical expertise behind. And that's when I did a research and I found out, okay, there is a course which exactly serves the purpose, which is for somebody who is good at math, somebody who is good at statistics, somebody who is good at programming, and somebody who wants to closely work with the business. That's how I ended up reaching the United States in 2014 to do my master's in analytics uh, from University of Cincinnati. I graduated in 2015. Since then, I worked with a leading healthcare analytics firm called Inovalan. Uh, Inovalan is a leading healthcare analytics firm in the US, helping out a lot of healthcare programs in the US with the help of advanced analytics. And in later part of 2019, I joined Verizon, and that's where I'm working as a data scientist right now. All right. So do you all realize that we all have been using some kind of data science in real life? Let me take through a small story. The picture on the left, whom you see, is my cute little 3-year-old daughter, Azra. She likes to play with toys. She likes to do cycling. She likes to run around. But one of her favorite toys is to play with puzzles. So when I bought this puzzle for the first time for her, she was not able to solve it by herself. So of course, that's how it is. So I tried to train her on how to solve the puzzle. So this is an algorithm that I came up with. These are the 5 steps which I taught her. I asked her to identify what are the corner pieces in a puzzle. Solve that corner pieces first. As you see in the picture 3, I have solved all the corner pieces. Then in the picture 4, I asked her to solve the side pieces, because all these side pieces and corner pieces look different from other pieces. And then in the picture 5, we have a complete puzzle solved. So knowingly or unknowingly, what we have done here is we have actually solved a data science problem. So why do I call it as data science problem? Any data science problem has these characteristics. It has a problem to solve. It has some kind of data. It does some kind of prediction. So let's take one by one. In the picture number 1, all the puzzle pieces we see in the puzzle board are actually data. What we want to do, we want to predict, okay, I'm getting that piece in the picture number 1. I want to predict, or my daughter wants to know where exactly she has to fit in. So that's a prediction, what I call. Now, if you see this puzzle board has 12 such pieces, if I trained her, knowingly or unknowingly, her brain is getting trained to an algorithm. By seeing that shape of the puzzle piece, she is able to fit it in the right place on the board. So I gradually trained her. Uh, in a data science world also, we train the model with the data. Now, in this case, the data is the puzzle piece. So she uses all the 12 rows. It runs through her algorithm in her brain, and then she decides where does the puzzle actually go and fit. Sounds good. I dismantled this puzzle piece again. I give to her. She solves it again. It all sounds good, perfect. But there's a problem with this. How do I know that whether she has actually mastered the algorithm for solving this puzzle, or is she just solving the picture? So that's a very important concept in data science, and that's where we have to validate her algorithm. So now this is a testing phase. If you see here, I am giving her, we were solving it with a 12 piece puzzle earlier. Now we are going to solve with a 24 piece. So if she has learned that, if her brain has learned that algorithm, she has learned that problem, or whether she has learned the instance of the problem. That's what we are testing here. Now, as you can see, she has solved the bigger puzzle, which has 24 pieces. And that's what I call it good data science model. A good data science model will operate very good with unknown data. Now, in this case, we were giving an unknown data to her model. We were feeding it with an unknown data. She identified the corner pieces. She identified the side pieces. She exactly followed that approach, and she solved the problem. So that's an example of a data science problem. Now, let's talk about a brief about a modern data science history. So the term data science actually started appearing in, I'm sorry, let's see. Oh, okay. Yeah, so if you see the timeline, you can see it was in early 2000s, the data science term started getting used in some academical journals. In 2006, the data science term appears in the cover of IFCS. IFCS is a non-political and non-profit a scientific organization for data analysis. So that's when people start getting to know more about data science. In 2011, uh, DJ Patil, who was the chief data scientist of the United States from 2015 to 2017, published a book on setting up data science teams. It was not until 2012 this thing started getting really picked up. Forbes calls data scientist as the sexiest job of the 21st century. And since then, data science has just grown exponentially. If you see in 2019, Python, which was just a normal programming language in prior years, has become one of the most used programming languages in the world, thanks to data science. All right, so let's talk about what exactly is a data science. So if you just Google on what a data science is or what a data scientist is, you'll get a lot of definitions. I would say nothing of that is wrong or nothing of that is 100% perfect. So according to me, which I found suitable is a professional who is able to solve complex business problem, who is able to relate data to solve that business problem, and at the same time communicate all this finding to the business. That is someone whom I call a data scientist, and that closely aligns with what I do at my work as well. A data scientist is somebody who is good at statistics, then a computer programmer, who is good at computer programmer, then a statistician. That's what a data scientist is all about. If you see in the Venn diagram, a data science has an equal mix of data analysis, it has equal mix of machine learning, it has equal mix of statistics as well. So let's talk about why actually do we need data science and how do we do it, what do we get out of it. So why is it data science? If you see, Amazon was not a significant market shareholder in 2000 to 2005 timeframe. Amazon was just getting picked up in the online e-commerce space. But there were very big retail centers in the US called Macy's, Sears, Target. All of them hold very big market share back in 2000s. But most of these stores are getting, when we reach the year 2020, we can see that most of these big retail stores are getting closed down. The primary reason is these big retail stores, they never believed in e-commerce, the power of e-commerce. What happened is Amazon won the market there. Amazon holds the biggest market share in that space now. So why I brought the example of Amazon and the big retail, all of this is, if you don't learn, if you don't unlearn, relearn, you're going to lose it. So that's exactly what is going to happen with data science. If you see the data growth, exponential data growth from 2010 and the predicted growth till 2025, you can see it's growing like, I think 50 or even more than 100 times. If there is nobody who, if there is nothing or no one who's not analyzing this data, who's not making meaningful insights of this data, if there is any such organization, they're going to lose big time, just as the other retail stores lost in the US. One more reason is, that's from business perspective, from an company perspective. Now there's one more reason. With this huge amount of data, we cannot have humans just sit on writing some statistical formulas and then finding out the patterns, finding out the recommendations. We cannot have that. We need machines. Humans are intelligent, but machines are faster. So what we need a mix of both. We want humans to command the machines to what to do. And that's what is machine learning. As we have seen in COVID-19's example, we saw China using artificial intelligence to stop the pandemic. They combined the geospatial data with the patient's information. They were able to prepare many analytical models based on this. And finally, they were able to contain the pandemic. All those are in news. I guess everyone has read about that. So let's take an example. What you see here is a simple formula: y is equal to x plus b. If you see on y-axis, I have just put house price, and on x-axis, I put living area. So basically, I'm trying to predict what would be the price of a house price be given I have the living area. Can anyone guess what would a and b stand in this? Very simple. I guess we all have learned this in our mathematics classes in school days. Uh, can anyone assume what would be a and b here? You can use your chat box to respond. All right. I'm not sure if you're facing any issues. Okay, basically, what I was coming at is, you could see that this is a very simple formula where uh, b is just nothing but 0. A is just one. Yeah, sorry, I'm not sure if I was clear on the question. I was asking what would be the values of A and BB. All right. So you can see this is just a straight line uh, with y is equal to x plus b being 0, a being 1. The value of y is same as x. So why did I present here? This is actually the basic concept behind a very basic machine learning model called linear regression. As we all know, if you just give x-axis a value of 2, you get y-axis also 2. So this does not happen in real life. Let me show you real life data. Uh, all right. So as you can see here, this is a actual plot of sale price of a home versus the living area. Now, how do you predict? Let's say if I have a living area of 2,000, there is sales price ranging anywhere from $100,000 to $400,000. It could be anything. So what can we do in this case? A simple prediction like this is not possible, but what can we do best? Probably we can draw some line which gives us an estimate of the best prediction that we can do. So let me draw 3 lines. I draw a blue line here. I draw an orange line. I draw a black line. Uh, what do you think is the best estimation of this prediction? Uh, I'll just watch. Perfect. Super. Yeah. So that's right. It's a blue. It's a blue line that is the perfect estimation of this model. Why do we say blue is the best estimation? Because if you calculate the average error from each of these dots to the blue line compared to the orange and the black line gives us the least average error. That's why we selected blue line as the model. Now, this exactly is the concept of a very basic machine learning model called linear regression. Yep, thank you. Uh, yeah, I'm sorry, I'm seeing something written on the screen. Yeah, that's right. The answer is blue line. You're perfectly right. Yeah, you can use the chat window for answering. Thank you. Uh, all right. Yeah. So what I'm coming at is now this is a very simple case. We have only one field. We have sale price to predict, and we have only one input variable called uh, the living area. But that's not the case in real life. We would have hundreds of such predictor variables to predict the response variable called sales price. So is it possible for humans to do this job? Somebody just sitting here and finding out the patterns, drawing these lines again and again? No, that's not possible. That's why we need machine learning models. Just see, just human thinking about all this mathematics in our brain. That's not possible, right? Now, how do we do it? Now we saw why do we do it? How do we do? We use predictive models. What does a predictive model do? A predictive model accepts data as input. It throws out a prediction. So in this case, let me give you an example. So in my project, we often, I work with closely with the marketing team. The marketing team always wants to know, hey, Afan, just tell me who are the customers who are highly likely to just leave us in the next 30 days. So I analyze all those data, I prepare a model, and I give something like this. I give the prediction to them. So what do they do with the prediction? The predictions would be a probability of each customer. Let's say we have 100 customers. I would give a probability assigned to each of these 100 customers, and the business can make the decisions. Which customers should we target for marketing? So of course, the members with higher probability to churn out will be targeted by the business. So this is how we build data science models. Now what do we get out of it? One thing is automated learning. We don't need humans everywhere. uh, it saves us time. For a business, it reduces the cost. That means more business. If you just see, this is an example. Let's say we have 50,000 customers with us, and there is a segregation of these customers which we do not know. There are some customers who are really good. There are customers who are not that good, who are just okayish. There are customers who are very bad. But we do not know until we run a predictive model on this. Once we run a predictive model, if you see here, if you see the last row, our return on investment. So let's say we have 50,000 customer. My cost to target these customers is $0.50 per customer. That means $25,000. If I were to target every customer, my cost is going to be 25,000 and my revenue is going to be 66,500. So what is my return on investment? It's only 2.66. Now, as a data scientist, I tell the marketing team, hey, guys, you don't have to do all this. I'll show you an easier trick. I'll show you the top 10,000 customers for our organization. You just need to target those 10,000 customers. And what do you get in return? You target this 10,000 customers, your cost is only 5,000, but your revenue is 50,000. And what is your ROI? 10:1. So this is why data science model is getting very popular in the business world. Data science do have applications for human life, a lot of other things in biomolecular scientists. Everybody uses machine learning and data science. But this is why we are hearing a lot of hype with data science these days. I hope that was clear. And I guess I don't need to explain this. We have seen real life cases of data science, applications of data science. Uh, Anyone who's shopping on Amazon knows that Amazon recommends us product. Netflix does recommendation. You see, I watched Zoya Factor movie and now this is what they recommend me. They have their own algorithm. So what runs behind this? It's all machine learning, data science models. The algorithm might be different from Netflix to YouTube, but that's what it is. Now, self-driving cars. Tesla is a leader in self-driving cars. We have artificial intelligence in each of these cars. The cars are able to identify the obstacles. It is able to identify pedestrians crossing. It is able to identify the red signals on the traffic signal. So all of this can be achieved through artificial intelligence. And artificial intelligence is nothing but it's built on machine learning, data science. All right. Now I get into the second section. What does a data scientist do? So oftentimes people think that data science job is only about preparing models, just generating the models, which is true. But these are the 8 steps which I have found, which any data scientist does in his role, which normally does not get discussed. So let's go through one by one. The first purpose of the first step in any data scientist project is to define the business goal. The business team, they come up with a request. Let's say the marketing team, in my case, they come with a request. And let me tell you one thing. People think that data science is a black box. It has some kind of magic. They can just get each and everything out of it. But that's not the case. So that's why we have to analyze the business request, go back to the business, and define the actual goal. What do they actually want? So here is a sample conversation between the marketing business unit and a data scientist. So the marketing business unit asks a question. We want to know the customers who would add a line to their account in the next 30 days. By the way, this is a real scenario which happened in my job. So I asked the question, is this for existing customers? Okay, they say yes. Then I asked them the question, is this for phone, tablet, or mobile broadband lines? So in US, it's slightly different from what we see in India. Each line has its own specific purpose. You can either buy a phone line, you can buy a tablet line, or it could be only a mobile broadband line. And a customer account means a customer account can have multiple lines. So for example, if I am the account owner, I could have 5 lines under me. So it could be my wife, my friends, or somebody else. So that's how the setup is. I'm just giving you a background. Now their request is to know whether I would add a new line or not. All right. So now I ask the question, is this for phone, tablet, or mobile broadband lines? So now they reply, okay, we need it for all three. So I say, okay, then that is going to be three separate data science model. I ask an extra question. Do you want to know if a customer who already has a phone line is going to buy a tablet line or that cross sell or vice versa? So what they say is, no, we just want to know if a customer has a tablet line already, will they purchase another tablet line? All right, that's fair enough. So now I define my goal. I change my goal. I tweak it to say that, okay, identify the Verizon customers who are highly likely to add a new line in the account for the same product type in the next 30 days. This is a very crucial step because if you don't define your goal, you are going to uh, mess it up. The model is going to get messed up in the end because you're going to prepare something on an assumption which was not actually what the business meant, and then you prepare, they wanted A and you prepare B, and it gives some other output which is of no use to the business. So that's why this step is very important in a data science project. Now the next step is data cleaning, data gathering. Basically now you have the goal defined. You want to know where can you get this data. So for that, you need to talk with the data warehousing team. So any organization has a, we have some marketing team. Now we are the data science team. Now there is somebody who is sitting in the IT side who knows very well about the data. They are the masters of data. So I am expert in modeling purpose. I would gradually learn more about the data, what it means, all of those stuff. But there are much better people than me who knows what exactly each field means. What I mean by that is, let's see the salary here. Now, I see a lot of values in the salary, but I don't know what exactly it means. Is it pre-tax salary? Whether it is post-tax salary? I see there is bonus percentage. Has the bonus percentage being already applied to this salary or not? Or do we have to apply this beyond this? So there will be a lot of questions. This is just a sample of a question which it just came to me, but there could be a lot of such questions that we would have to answer. So that's when we talk with the data warehousing team and try to understand and try to get the best data which is available in the data warehouse. So we tell them, okay, see, team, I want to get the data, the customer information. I want to know what is their internet usage, what is their data usage, how many minutes do they talk per day. I need all those kind of information. So what I do is I actually talk to the experts and get that information. So that's one thing. Now second thing is, you get the data, but oftentimes the data is not clean. As you can see this example here, the highlighted examples in gender, uh, in the line number 20, the gender is missing here. It's missing here as well. Uh, is there any other missing values? Yeah, I think there is some missing values here as well. Here as well. Yeah, all this. So there are some techniques which we use. So so in this case, I think mostly I would be replacing it with male because the male appears a lot here. So those are some of the techniques that you have to actually deeply analyze the data to find out what to do with the missing rows. Either add uh, either delete the row, or whether you want to replace it with the most appearing value. So if it's in numerical, we might replace it with the mean, mode, or there are a lot of things which we can do. The reason why I say all this thing is, you a lot of you are students here. You might be learning models, but you have to keep all these things in also in mind while you work on model, what actually happens in a real life project. Okay, the next part, data exploration and visualization. This is an interesting thing. So now we are kind of reaching that model stage. We defined the goal, we cleaned up the data. Now let's do some kind of exploration. Now, what do I do in this stage? Let's say I'm working on a project where my goal is to identify any customer who is going to add a line in the next 30 days. So what do? I explore various features which I think would be beneficial for the model. So some things which come to my mind is internet usage. Probably, I mean that those all are transactional data, right? The talk time of the customer, number of internet lines the customer had, number of hotspot lines the customer had, paperless billing lines, etc. A lot of things. I can think of 100 such features. I analyze each of these features one by one. It's a very time consuming process. You need to be patient, but that's what you have to do. Now, what is the next step? I try to do some kind of visualization to see, is there any difference between a customer who has added a line and a customer who has not added a line. So if you see here the difference, I've just taken some random three features. The first one is average data usage. As you can clearly see, the one here stands for a customer who has added a line, and zero is for a customer who did not add a line. As you can clearly see, there is a upward trend. For customers who are adding a line, their average data usage is higher. Similar with all these three features, the average talk time, the seconds of usage is higher for the customer who has added a line. Even though not in the same magnitude as the first two features, the third feature also has a difference. Uh, the average number of lines added by customer in the last 3 months is higher for the customer who is going to add a line the next 30 days. So these all are exploratory data analysis. So what do we do in exploratory data analysis? We know the input, we know what we want to what we want as the response variable. We are trying to find the relation manually. Is there any relationship between the input and the output? Once that is done, now is the step of feature selection and feature engineering. So till now we were talking about the properties, we were talking about characteristics, we were using different terms, fields, columns, all for these properties. Going forward, I'll be using the term feature because this is what we call it in a data science world. In a table, if you see, I'll just take this example itself. So all these are actually features: the salary, bonus, senior management team, last login time, start time, whatever we say. All these are actually features. All right. The next step in the data science process is to do feature selection. Now you would have identified hundreds such features which actually is making some kind of sense to you, which you think if you input to the model might improve your performance. But can we do that? Just imagine you are giving 100 different features uh, to the model, then it would have been very easy, right? We just give the models and just say the model learns itself, uh, and then we just go with the output. But in reality, the concern with that is there could be some features which are very important for the model and some features which are negatively impacting the model, which does not add any kind of predictive value to the model. It hinders the performance of the model. So that's why we need to do feature selection. And one more reason why we do is if you have 80 to 100 features, it's there is going to be definitely going to be production issues while you implement it. It's hard for the software development team. At the same time, it's also difficult to explain all this to the business. With any data science model, we have to explain the features to the business because they also have to understand. Ultimately, it's a sales team who is going to make the call whether uh, to do a marketing call or not. So for that, they need to understand the model, they need to understand the business, the features, everything. Now, feature engineering. So let me show you an example of feature selection. I have identified 10 features here. Uh, so this is again for the same model we are talking about, whether the customer would add a line or not in the next 30 days. You could see that the feature importance is varying between each of these features. The first 5 features, I don't think it's that really important. These features are really important. So by going through the feature selection method, I select the only important features uh, in this model. So in all of the students or who is working on data science or who aspire to data science, try to learn things like this, how to select the most important features for your model, how to do feature selection. These all are important as you go forward. Now, I think somebody's using the chat window. Just give me a second. Okay, all right, no problem. Uh, Yeah, now the next step is feature engineering. This is also a critical step in a data science models. So for example, your input might be having many fields like, or many features like men or female. uh, and as you know, data science models are mathematical models. You cannot input men and female to a data science model. You have to convert it into a numerical variable. So that is one example of doing a feature engineering. Another one is extract information, day information from date. So probably a birthday of somebody, we want to calculate the age, or we want to uh, do some kind of operation on the date, and the information available is May 29. So you can extract few information from this. You can extract 29. You can extract that it's a Friday. Again, the Friday has to be converted into 1 and 0 again. And then you can also extract the date, uh, m- month as 5. All right. uh, how do I remove this? All right. So another thing which you do is the natural logarithm of the feature. So why do I do this? Let me show you an example. uh, I see something on the screen. Can you please remove it? Oh, all right. So the normalized data, what do I mean by normalized data? This is an actual histogram of an original data. It just shows you the frequency of each data point, how much you have it. So every machine learning model performs well when the input data is normalized. So in order to normalize the data, so this is what a normalized data looks like. So anyone who has a stats attended stats class, you probably already know much better than me. But every machine learning model works best when the data is normalized, and that's why we have to do a normalized data. So this also comes under part of feature engineering. Something else which I wanted to talk about: where does a data scientist excel in feature engineering? You have machine learning model, you can just input the data, internet usage or talk time or any such feature. But where do I make the difference to the model? So this is where it is. The internet usage is being I create 5 different features from one single feature. So I have I might have only one field in the data warehouse, which is called internet usage. I create 5 different features: average internet usage in last 3 months, average internet usage per line in the last month, and so on, and number of lines that used more than 3 GB of data. Why do I do this? Because each of this might have different importance to the model. The model does not know uh, the model does not know what exactly it needs. So that's what we have to supply the model with. If I give this 5 different features, it might recognize some of these features as very important and very having very high capability predictive power. So we discussed this. Okay, now we did the feature selection, feature engineering. Let's go to training and building the model. Now this is the actual step where the model is getting built. On the training the model and finalizing, what we do is we actually uh, decide an algorithm. Uh, I'm not sure how familiar you guys are with algorithms. Like it could be a linear regression, logistic regression, classification trees, all of this. So in this case, we are actually doing a classification problem because we are just our output predictor variable is either 1 or 0. We want to know whether the customer would add a line or not. So this is how we do it. We have an input data. We train the model. The model does some kind of prediction. We calculate the metrics. The metrics could be the accuracy or it could be the error rate. We check it. We do any significant changes if we need, and then process the data again, train the model again. And this goes in a very in a circular fashion. You need to do a lot of trial and error methods. So once I do all this, I prepare 3 models. I have one model which is based on the logistic regression algorithm. One is based on the random forest algorithm, and one is based on the XGBoost algorithm. As you can clearly see, the XGBoost algorithm has got the highest accuracy for my model. So I go ahead with the model which uses the XGBoost algorithm. I've simplified this actually. The in actual world, accuracy is not the metric that you consider. There are a lot of other things we have to consider, but just for the ease of explaining all these things, I just used accuracy. Now we have finalized the model. Now in this step, we decided, okay, we are going to go ahead with model 3. What is the next step? We need to test and validate the model. So what is test and validation? In data science world, let's say I have 100 records, 100 rows. I would not be building the model with all the 100 rows. What I would be doing is I would split the data into two separate parts. One is the training and one is the test data set. So normally the split is like 80% in the training, 20% in the test. Again, this all are very subjective to the specific problem that you're trying to solve. So the idea behind this is you train the model on 80%. Just as we discussed about my daughter's case, uh, if I give the same data to her again and again, I'm pretty sure she is able to solve that. So that's not what we want. We want to know how our data science model will operate with an unknown data. That's why we split the data into training and test. Now I build the model on 80% of the data. I do my testing on the remaining 20% data, and that's where I calculate all my metrics, whether it be the accuracy, error rate, or true positive rate, whatever it is. Then I compare the test results for each model, and then uh, I decide which model to go ahead with. So there are models like neural network models, which you probably are aware. The neural network models are really good, but the problem with that is it's very biased to the data. So if you give any kind of data to this model, it will solve you 100%. It will operate very well on a training set, but it might not operate well on a test data set. So that's what we do here. Now validation on unknown data. So that's while training. But again, in the same example, let's say I built the model. Uh, I used data from 2019 November or 2019 September to 2019 December. I split the 4 months data into training and test. I did all of this. I decided the model. Now, before I send this to production, I do one more thing, that is validation. So I take the January data, which the model has never seen. I do a validation run on this and see what my metrics looks like. So that's what we call as validation. Now the final step. This actually is not a data scientist job. In some organization, data scientists do. I don't do this, but what we need to do is we need to automate the model, right? So basically, we deploy the model in production with the help of the software development team. They create an executable of the Python code, uh, or we have other tools, softwares also, which actually helps us in this process. You create the model is being an executable file of this model is created, and the software development team actually submits this to the production, and then it's all automated. We help them, we tell them what data you have to provide to this model and what to do with the prediction. So what normally happens is they write the prediction, the customer information to a table, and we process that table and give it to the business decision. So that's about what a data scientist does in real life. Well, so let me just take a pause. Let me ask you a question there. What do you think is the most easiest job among this? Don't consider step number 8. What do you think? And let me add one more thing. Most of these steps go in an iterative process. For example, I might be doing feature selection, training the model together. I might be doing the data cleaning and data exploration together. A lot of things like that. But do you have any uh, like a wild guess? What would be the easiest step, or what would be the most toughest step in this one? Again, you can use the chat box. And all right, great. Data cleaning is here. 7. Shahid says 7 is easy. All right. Any other responses? 1 tough. Wow, that's great. Uh, yeah, I think somebody's replying me privately, but yeah, replied to the everyone. All right. Unlike said that is not much as easy. Great, great. Uh, 7. Yeah, I'm receiving great responses. Okay, let me tell you one thing. The easiest step is the model preparation, the training the model. It could be either 5 or 6 or 7, whatever you call it. That's the easiest step. The toughest job, it comes in the beginning part, defining the business goal, doing the data cleaning. uh, Data exploration is kind of interesting, but data cleaning is the most part where I get the headache, because you need to just sit on this. It's all manual task, and then keep on doing. It's not an easy task. Yeah, great responses. Thank you, guys. Yeah, I think Shahid is saying 2 is boring too. Yeah, you're right. 2 is actually very boring, but this actually happens in a data science world. Um, Before we move to the next section, can I request some? There is some red, uh, nice figure on the screen. If you could remove that, because I'm getting slightly distracted. I don't know who drew that. If it is possible, I don't know even how to remove it. Uh, is there any? I don't know. Okay. Um. Okay. Somebody's private messaging. Your click connected. Uh, I'm sorry. I'm not really good at it. So let it be there. Let's move on to the next section. So now let's talk about what a data scientist toolkit is. A data scientist, uh, somebody like me, there are different flavors of data scientists. There are people who work closely with the business. There are people who uh, work very closely with the product. Their main responsibility is uh, to create microservices, to create APIs, so that other services in the product uses their machine learning algorithm and gives them an output. But I don't work in such a space. I work in a more closely business aligned space. Uh, my responsibility is to help the business achieve better ROI, reduce their cost, things like that. So I don't work with any such product as such. So what I use here is, for data exploration, I use SQL. For In our organization, it's Teradata, but it could be MySQL, Microsoft SQL. I'm pretty sure most of you are familiar with this kind of tools. Then there is Python and R. There are organizations that use Python and R for data exploration and cleaning. For data visualization, I use Tableau. Again, there are people who use Python and R. For machine learning models, I use a combination of Python, R. Then Jupyter Notebooks is, again, it's using Python. Uh, there is something else there is a software called Data Robot, which actually builds the machine learning models for you. It does a lot of, it makes our job very much easier. There are softwares like that, but these are our licensed tools. I don't think it's available for general public. But yeah, that's what I use at my work. Now, these are some examples of tools which I use. So I've just taken some screenshots of Tableau, Jupyter Notebook, RStudio, all of these things. All right, now let's get to the interesting part. Now, I'm not sure whether you guys enjoyed the job of a data scientist or not, but I am of the assumption that there are many people who are sitting here who wants to know how to become a data scientist. As you would have seen in my profile, I had a very diverse background. I came from uh, an electronics and communication background. I did software programming. I did my MS in analytics. I worked as a financial analyst, and then I ended up as a being a data scientist. So my advice is this is something which anyone can do. If you have some time which you can keep for yourself, train yourself on all of these things. Switching your career to data science is not that far away. So let's see what I did. Here I'll be sharing my experiences, what worked best for me. I would advise you to listen to many other data scientist experience, because each and every data scientist experience is entirely different. They might have entirely different view of things. So as you attend more and more webinars and sessions, you get a very clear picture of this. So this is what I did. Learn the basics of machine learning. uh, there's a course on Coursera. It's called Machine Learning About. Uh, it's an I think this exactly is the course name, Machine Learning Stanford in parentheses. Andre Ngo is an professor at Stanford. He explains the concepts behind the basic machine learning models very well. uh, you will get to know the statistics. Even if you don't have any statistics background, it's very easy to follow his lessons. I would highly recommend you to, if you would like to make this career choice, finish this course first and then move on. Every machine learning model in data science is a glorified linear regression. So if you know how to do, if you know the math behind linear regression, logistic regression, neural networks, that's all what you need. Everything else is a glorified version of it, and you don't need to know the math or stats behind any other models. You can just use it in your real life projects. This really yeah, as I said, it's a foundation to all other machine learning models. Then you could either use Python, or you can use R Studio. uh, both of these tools are very good. I personally prefer to do on Python, because there are a lot of libraries on Python which really helps to solve data science problem, especially related to data cleaning, data exploration, all of these things. So I would recommend, uh, you don't have to really learn Python as a language, but what I would recommend is to go, I don't know if you are aware of this website, www.kaggle.com. uh, I'll just take a snapshot of it. I'll see if you can, are you able to see my screen? uh, yeah, so this is the Kaggle dashboard. um, all right, great. So I have done, this is my profile. I've done 2 projects on this one. This immensely helped me. I'll tell you why. So this is the dashboard. When you see, when you log in, you click compete. Uh, you see a lot of competitions here. So these are 2 competitions that I participated in. Uh, then there are a lot of other competitions. You can learn everything from here. Believe me, this is much better than what I do at work. At work, there are limitations to what I can do, and I don't really need some very big analytical models to get the work done. But here you are competing against the world. You can see a lot of very good analytical projects. If you just click, like this is in project sentiment extraction. If you just click on it, uh, you'd have the description of the data. If you just click the notebooks, and let's say I'm just selecting Python here, you see a lot of codes written by multiple contributors here. You can go through each of these projects, each of these notebooks, and learn how to do how to code in Python, how to do data science, machine learning projects, all of this stuff. So I just wanted to share this with you. This really helped me. Uh, sorry. All right. How it helped me is, if you, let's say you participate in one of these data science competitions, you will have a lot of people sharing their code. You can learn from that. You can add your own ideas to that, and you can be one among the top 10 percentage or top 20% leaderboard, the employers very highly value this thing. If you have if you are in top 5 percentile or top 10 percentile, or if you just did some kind of project on Kaggle and you're somewhere in the position in the leaderboard, the employers highly uh, recommend that. They really do notice that. I, from my personal experience, I have got many calls for a job interview after people saw my Kaggle ranks. So I would highly recommend. This is a great learning experience. Now, with Tableau, there are a lot of openings with data visualization analyst. Uh, if you don't want to take that track, Tableau is a good skill to have even for data science projects. You need to have some kind of data science, data visualization, data exploration, all of this stuff. The Tableau actually helps. And there is one more area where Tableau actually helps you. Once your model is created, you might have to create dashboards for the business to see what is the input, how is it performing, all of this. So I do get that kind of request. I create some Tableau dashboards for the business to see how good the predictive models are performing. This is few other things like I would recommend to visit these websites like data.gov. You get this is a government sponsored data set by the US government. There are a lot of data sets in this. You can use it for your personal projects. Then there are a lot of data sets on Kaggle, which I just showed you. There are a lot of competitions. There are data sets associated with it. There are data sets which are not associated with competitions, which you can still use for your personal projects. I would highly recommend that also. And uh, this is my one of my personal connections, wizwiz.com. So once he took a session while I was in the university, I've seen great, excellent Tableau tips in this website. So if you want to learn Tableau, I would recommend visiting this website also. He has done very excellent things. I learned a lot of things from his dashboard. So those are some of the things which I would recommend for anyone who wants to become a data scientist. Try to do at least 10 lines of Python or R. I would recommend Python, to be honest. Do some kind of project, do at least 10 lines of code, get yourself familiarized with Kaggle. Do try to see what are people who are upper on the leaderboard doing. What is their project look like? What do they infer from the data set? Try to understand that. So that will really help you to choose your data science, to focus your career on a data science related role. Now, these are some skills which uh, you might not need, or sometimes you might need to become a data scientist, or I mean, to get a data scientist job. But these are actual skills you need once you become a data scientist. Analytical skills. I would highly recommend you can see in my job searches here, I have seen many employers not asking me anything about the coding part. Really did not care whether what is my expertise in Python. They just asked me a question. Okay, do you know Python? Have you worked on Python? That's all. But what they really looked for in me is whether I have the right analytical skills. They would frame me a business problem. They would tell me, okay, once an airline's uh, one flight tracking company, they called me and they asked me, okay, Afan, tell me, we work on safety of flights. What do you think some of the features that actually impacts the safety of the flight? So I've got many such questions. They really wanted to know, how do I think analytically? What do what will help me build my model? Second thing is patience and perseverance. You could have, I have faced this. You could have days or even close to 1 month without no improvement on your model. Recently, I worked on a customer frustration model. There was no data, there was no good data. I just had some IVR customer information, customer calling information, very few data. You would have such projects. So what you need to have is you need to have patience. It might get boring at some times. You just need to just sit there, do your project, stay motivated. Yeah, that's saying in related to the point number 2. good communication skills. This is very important, especially if you're working as a data scientist in a business world. The business team, as already mentioned, they need to communicate. You need to clearly communicate this is not possible. You need to clearly communicate what the model is about, what you can expect from the model, and try to understand what their pain point is, what their concern is, what their problem is. And lastly, the courage to question the data. Again, it's related to the what I told before. You cannot just sit, accept whatever your business tells. You cannot just give whatever they ask you to do. You might have to talk with 50 or 100 different people to know what exactly the problem is. You might have to understand what the data is, a lot of things. So you need to have that courage to question the anomalies in the data, the patterns in the data, which might be different from the understanding of the business. All right, guys, with that, we come to the end of the webinar, a data scientist journey. I hope this was really helpful to uh, to give you an insight about what a data scientist does, and for those who are interested, how to move your career to a data science focused role. I believe I covered all of these topics. Now let's move to the QA session. I prefer this to be a very interactive session. Please feel free to ask any questions that you have about this field, data science. Uh, I would try to answer as much as I can. Uh, I'll, to best of my knowledge with my experience, I'll try to answer it as much as I can. So please feel free to use the chat window again for the questions. Thank you. Uh, oh, Fatima, I just noticed that the time has, but that's fine. I guess it's okay with all the participants here. I'm okay with the timings. Uh, so let me go to the questions. Let me see. Hari Krishnan has actually for visualization, I use the open source knowledge BI tool because it's free. Great. Are you referring to the Microsoft BI tool or any other tool? I'm not sure. Yeah, it's up to you. Whatever you're comfortable with, just go ahead with that. There's no right or wrong in this one. What you want to know is you should solve a business problem in hand. Whether it's a whether the whatever the business wants to know, whether we can solve with the data or not. If you know to solve that problem, that's what we need. It doesn't matter what tool you use. Great. Excellent, Hari. And so there is any course for beginners in data science. The same course which I already said, the Andrew NG machine learning. I strongly believe data science is not something that you should learn through the courses. The courses can guide you, but your success in data science depends on the projects that you do, and that's what matters. I've not seen many certifications on any data science programs, even though people try to sell it. But what employers really matter is whether you did a project or not, because many organizations has a lot of data. They don't honestly, they don't trust the certification. They just want to know whether you are capable enough to do the problem, or whether you have that right analytical skills, whether you have done similar projects in the past or not. So I would highly recommend to do some project, which I already mentioned as in kaggle.com. That's your way to go. Uh, Great. Thank you, Aparna. Uh, sure. Very excellent. What is the most important skill of data scientist? Very, very, very good question, I would say. Uh, what would be the, so for me, again, I'm talking from my experience. You would have, I would recommend you to talk to many other data scientists, because perception of each and every data scientist is very different. For me, the most important skill what I have noticed is the analytical skills, to think analytically, to translate the business problem into a data problem, finding out the data, the communication skills, the ability to communicate with the business stakeholders, identify what their pain point is, and translate that uh, into a data science problem. That's the most important skill. The Python, Tableau, whatever you think of, these are skills that you can learn any day. Doesn't matter. But having being said that, I am talking from a US job market perspective. That might not be the same case with an Indian job. Because I've heard there are many Indian CEOs who highly recommend programming and coding skills. So it's a personal choice, but this is what I think. Analytical skill is very important. All right, great. Thank you, sir. And yeah, thank you. Hope happy to know that it helped you, sir. Hi, sir. Is it necessary that we should specialize in some statistic related studies? Uh, I think it's okay. You have some statistics, but that's not everything. As I said, data scientist is somebody who has better statistics knowledge than a programmer, has a better programming knowledge than a statistician. So you need to find out that right path. But I would not recommend to spend too much time on statistics. You need to know statistics. You can do it on your side, but that's not the main thing. All right, great. Thank you, sir. Thank you, sir. Thank you, guys. All right. I think I saw few people raising hands. Can you please uh, put your session question on the chat window? Uh, I don't know how. Mm, yeah, please, is there any question remaining? Uh, Great. Thank you, Rajani. So I hope that's it. I hope there are no much questions again. Uh, all right, I would like to share my LinkedIn profile in case you have any question related to data science career or anything of coming for higher studies in US, all of this stuff. I would be really happy to help you guys. So this is my LinkedIn. All right, yeah. So okay, sir. Thank you for the information. I hope there are no questions coming in between. All right. All right. Yeah. So you can connect me on LinkedIn if you have any questions related to this or anything else you want to know related to data science. Again, I'll try to help as much as I can with my limited knowledge. This is such a big field. Uh, there is the, there are a lot of things going on, and something which I did not cover here is uh, about the deep learning, image sensor. Then there are things like web scraping, text mining. These are not areas of my interest, nor I have much knowledge about all these things. But that's an excellent field. There is a lot of scope, especially the text mining that has evolved over the last 6 months. So some people are okay. Yeah, Safa has asked a question. How important are self project? Very important. If you were to ask me, is there a single thing which I should do from the list which I already mentioned? Uh, Let me just take this. I would say doing any kind of data science project or stands above any course anytime. So that's a very important thing. If you can learn the basics of machine learning, quickly jump onto your data science project. That's the most important thing you have to do, I guess. Yeah, I'll just somebody has asked me my LinkedIn profile. Let me just see if I can get it from. All right. So, all right. So I've shared my LinkedIn profile as well. I guess uh, that that helps. Who was asking for LinkedIn profile. So again, let me reiterate. I hope this session was helpful to all of you. Um, I would if there was something which during my time, during my period of my masters that I did not do, and I committed that mistake, that would be doing a Kaggle data science project. So I would highly recommend to do that project. I'm not disregarding any of the statistics knowledge or machine learning, but you need to have all this information. But for an interview, when you go, you need all those information. But highly stands out is a rank on Kaggle data science project, and I'm pretty sure you will also learn a lot of things while you do this all these projects. Keep statistics with you, learn all of those things, but do projects. Yeah, that's what I'm gonna. All right, great. I guess that's it. So, Fatima, do you want to take over? I'll just.